Youssef, thank you very much for joining me.
And thank you for having me.
And would you start by telling me, where have you seen GenAI deliver the most surprising improvements in pricing accuracy or efficiency?
No, that's a great question, Joanna. We started exploring a lot of the GenAI methods, numerical methods, in the context of deep pricing. A number of years ago, we started with a neural network. A couple of years, like last year, the year before that, with the GenAI methods, with VAEs and GANs. This year, we have explored the latest and the greatest in the tool bag, right, which is the transformative topology, which is used for large language models, GPT and so on. And what's interesting in the transformer, it's simply a neural network topology with an additional attention layer added on top. As simple as that. A lot of people kind of miss that nuance. It's simply a neural network with attention. And because of this attention layer that just happens before the processing of your kind of sequence in the neural network, it allows you, to focus the actual input on the relevant pieces. Attention is like, the attention in human beings. Neural networks were inspired by the way the brain was functioning. The attention mechanism, transformers, was also inspired by biology. Yeah? So you put the important pieces in the sequence in the front, you put the less important stuff in the background, and that's what the attention allows you to do. So when we started the work in the context of deep pricing, we conjectured that actually as you apply this attention mechanism to a neural network, it will allow you to pre-filter the important pieces of the input, and therefore the expectation is that the training of your model is going to be much faster, and the precision of your pricing is going to be much sharper. And that's exactly what we have seen, and that's what we spoke about earlier.
And what persistent challenges remain where traditional quant methods still outperform AI?
I think the main kind of challenges that are still there with the GenAI in general and with transformers in particular, it's the implementation and performance. Yeah? So when you are trying to train these models on GPUs, actually the calculations are quite fast. They're more evolved because you're operating on matrices, and therefore there are more calculations. But the limiting factor is the memory, because you're storing much bigger attention matrices in the GPU, and therefore as you're moving back and forth between the CPU and the GPU, it really limits the performance basically. So there is a whole lot of research that has been happening recently in terms of doing sparse attention, doing QV caching, and other methods like that really helps you alleviate the issue with dealing with large matrices that you are storing on the GPUs, basically, right? And that's kind of the new body of research that's happening right now.
And how is GenAI reshaping the required skills for next generation quants?
I think it's important, right? Because, as I was saying earlier, the way I look at GenAI is just another kind of numerical method. Yeah? So we have been using traditional Monte Carlo methods, PDEs and all of these kind of classical numerical methods. For me, personally, GenAI is just offering a new set of numerical methods. So neural networks is one of them. VAEs and GANs is another set of numerical methods. And now transformers is yet another method. Yeah? And therefore, the expectation as we go forward, as quants and people in the industry, is to be leveraging a lot of those kind of numerical methods more and more in the day-to-day, but just as a numerical method, as opposed to a separate GenAI application. Right? That's the next evolution in the way the quant role is going to go.
Youssef, thank you very much for your time.
Thank you for having me.